Okay, so here's a problem-solving technique for you. Basically, so this is the problem, yeah? So you have A, B, C as a triangle, and then circumcircle is drawn in, and then there's some point D on BC, and then you draw a parallel line from D that's parallel to AB, yeah? It meets the tangent at A at E, and then E joins C and meets the circle at F, and then you're trying to show that, okay, and then AC meets DE at X. You're trying to show that BXF is collinear, right? Or another way of saying it is you're trying to show AC, DE, and BF are concurrent. Okay. Okay, so here's one problem-solving technique that's particularly helpful in geometry. So assume what you're trying to prove is true. Okay. So this is a red diagram here, right? And if you assume it's true, you can see what you can try. What the red diagram gives you, the consequences of what the conclusion is. Yeah. And then you might be able to try to prove those little things directly. Okay. This is just an idea if you have no ideas. So for example, if you label the angles, alright, be quiet. Be quiet. So if you label the angles alpha and beta, yeah, then that angle is alpha plus beta because of the alternate segment theorem. And then you get a bunch of things. Can you see, like, because of the parallel lines, you get this is alpha. You know, because of the parallel lines, you get this is gamma. Yeah. And for example, you also get that this is vertically opposite, it's alpha. And here you get a beta because it's cyclic, yeah? So the beta, oh, we're assuming, sorry, I should have said, you're assuming BDEF is cyclic. Okay. So if that's alpha and that's beta, then gamma is equal to alpha plus beta, right? Because of bow tie, this is gamma and this is gamma, yeah? And then because of bow tie, this is beta and this is beta, yeah? So that's where the motivation comes from. For example, now that you know that gamma equals alpha plus beta, you know this is the angle bisector, right? And you also know that this is isosceles, yeah? So that's the motivation for why Leon proved it was isosceles and it's an angle bisector. And also, you can see a few things as well. You can see that, can you also see that A, B, C, this is E, right? A, B, C, E is cyclic. Can you see that? Is that obvious?
Yeah.
Okay.
You mean the bow tie ABC? Or the
sorry, I mean sorry, I mean something else. I mean ADCE, yeah?
Yeah.
Oh.
Because it's both alpha plus beta, yeah? So ADCE is cyclic, yeah?
Yeah.
Okay, so here's where a little bit of theory might help you. So I don't know if you remember the Broken Bay theory.
Concurrent.
Okay, so see, what if we can prove that ADC is cyclic, right? Oh, can we?
A, B, C, E.
Yeah, so let's try to prove that how about this? Let's try to prove that ADCE is cyclic. Can you do that?
Yeah, alpha plus beta, right? It is. Yeah, it is.
Is it obvious?
Yeah, it's obvious. On both sides, it's obvious. Angle EBC and angle EAC.
Okay, so it's cyclic because, for example, this angle here is equal to this angle because of alternate segment theorem, which is equal to this angle because of parallel lines, right? And so then ADCE is cyclic because of bow tie, yeah? Okay, I think I'm trying to claim that this solves the problem. The problem is literally this trivial. Okay.
Yeah.
And you think it's true?
So we have A ADCE cyclic, yeah? We have ABCF is cyclic, yeah? And we also have BDEF is cyclic, yeah? That makes sense? So we got 3 circles, yeah? Alright, we got 3 circles. If you look at, so there's 3 pairs of circles, okay? If we look at every pair, let's look at the points that are in common for every pair of circles, okay? So the first 2 circles, can you see it has D and E in common, yeah?
Yeah.
So D and E, yeah? Okay, for the second pair, the second and third circles, can you see that you have A and C common, yeah? Okay, and the first and third, you see you have B and F, yeah? So remember what the 3 things were meant to be collinear with? There's AC, BF, and DE, right? They're paired up like that, right? So this is what's called the radical axis theorem.
The totally random happening one. Oh yeah, the radical, yes.
So the radical axis theorem says if you have 3 circles, yeah?
Wait, how do we
Like
have
this,
multiple
yeah?
circles?
Huh?
How do we have multiple circles?
Because we have the original circle. We're given that BDEF is cyclic, and we just proved that ACDE is cyclic.
Oh, okay, I see.
So we have 3 circles. The radical axis theorem says when you have 3 circles, the radical axis between pairs of the circles, so like this is the radical axis between these 2. Say this is like the radical axis between those 2, yeah? And then the radical axis between these 2 are concurrent, yeah? Yeah. It's actually it's really easy to prove because the radical axis is defined to be the line where the powers are all equal, okay? Power of a point just means so if you have a point and a circle, the power is just defined to be so the radius, so the distance squared minus the radius squared, okay? So this is the radius. And a radical axis is a straight line, which is the set of all points for which the power between the point and each circle, one circle is the same as the power from that point and the other circle. Okay, so there's a theorem that says that's a straight line. Okay, and so if you have 2 circles that intersect, okay, the radical axis is actually the line that joins the points of intersection. Okay, because at the points of intersection, the power is 0. Okay, because d is equal to r, so d squared minus r squared is 0. Yeah. So if the power is 0 for both circles, then it's equal. Yeah, it's both equal to 0. And so those 2 points are on the radical axis. If we know it's a straight line, then it has to go through those 2 points. It has to be the straight line going through those 2 points.
I hate you.
And the thing is, if you have like another circle, like here, right, then it has to do that. Oh, I already told you not to throw it, okay? No, it's your fault. No. Blame yourself. Blame yourself.
I blame myself.
Yes.
I hate it.
You hate yourself?
I hate it.
Okay, no. Hating yourself is okay. But hating him is not okay.
Why? He threw a thingy at me. I what?
Wait, stop bullying him also.
Yeah.
Oh, no. It's still your fault. Okay? Worry about yourself. It's possible that you can both believe it's your fault, yeah? Yes.
It was Leon's story.
Is your name Leon? Then that confuses me. Okay, so this is how it works, right? So if you have these two meeting at a point, right? So can you see this point is the intersection of these two radical axes, yeah? It has the same power for this circle as it does for this circle. That's what it means to be on this axis, right? It also has the same power for this circle as it does for this circle. That's what it means to be on that axis. But obviously, if it's equal like that, then the first and third are equal as well, right? So that the third line has to actually also pass through that point. Okay. So that's the radical axis theorem in a nutshell.
Communism 101.
Wait, this isn't communism 101. This is how to be a better person 101.
We failed. Michael's class.
It's kind of like in basketball. It's like you know it's your team's fault, but you really have to just blame yourself and think about how you can improve.
Let's get one. Are you
Oh, so this problem is like one shot, but I think it's actually interesting that you can prove that the triangle is isosceles, and that's an angle bisector. I feel like that's actually more interesting than the actual problem.
Wait, what was the actual problem like in the first place?
Oh, to show that ACBF. So this is the actual problem. ACBFD is concurrent. So you can show it by the radical axis theorem. See. So we just need three. See, because the three circles, the radical axes go through the lines of intersection. Okay, they all intersect, and so they're exactly the intersection points. And they're not all my pings. I just got one ping. All right. I mean, 2020. You want to look at the 2020 stats?
Yeah.
So if you look at the 2020 stats, no. I think this is the year that Haibing did well. See?
Yes.
Whoa.
I
need to get 3 questions now.
We get 3 questions.
Angry.
Yeah, I guess how quickly you get the first question will determine how well you can do the other questions.
Where's Hayden?
Oh, Hayden's this guy who did IMO like five years.
Yo.
He's graduated from high school now, I think. All right. Let's have a look. So what's another country? Let's try to find the best country that's not able to get question 1.
China. Japan. Let's see.
I like.
Trinidad.
Sri Lanka. Wait, okay, I'll go with Sri Lanka here. Oh, okay, the score is very low, so. What? They still all. Oh, no. Half the team couldn't get question 1.
Is this how we make ourselves feel better?
Whoa. Hold on, you get 0 and you made this list for Sri Lanka. So they must really they select their 9, okay? In Australia you select 20 people in the top 10 make the list. In Sri Lanka you select 9 and some of them get 0.
Only 9 people went, probably.
Yeah. Well, because obviously if 10 went, then they got 0, they would make the list as well.
They had more than 9 people.
But it's very unlikely that they just made the max.
Actually, what's the population of Sri Lanka? This proves that Sri Lanka also has a really stupid APMO selection system.
How do they determine which people get to the top 10?
So by some stupid method that didn't guarantee everyone scored non-zero.
21 million.
Oh, what? They have this similar population to Australia.
Bro,
Yeah, so their system sucks even more than ours.
It's math.
If you have a system for selecting entries for this competition that results in 4 of your dudes getting 0 or 3 people getting 0, then you did something wrong, okay? Because you know you could literally just let your whole country take this test.
Isn't it only like below high school though?
High school, yeah. What did you say?
Try Japan. Let's see what Japan is.
Gives up.
Go Trinidad.
Let's see what Japan got.
Alright, hold on. Japan's too high class for this little search right now. Trinidad is more along the lines. What the?
7.
See, Trinidad and Tobago. This is also a poor selection system.
0.0001.
Second, third, fourth, fifth, and sixth all got
1 million.
1 million.
Yes, 1 million.
That's actually a city-state country.
Port of Spain. What the?
That's actually just a city-state country.
So 1 million. That's like less than the size of
Sydney.
Bangladesh.
Sydney's like 5 million.
Yeah.
Maybe like I don't know, South Australia.
I don't know. NATO. Canada is going to be part of Vienna. Yes. 128. It's like 7, 8.
Yeah, I still feel like even though they only have 1 million people, surely they have more than 10 people that get 1 point. Alright, so that you're going for Japan now, is that what you're saying?
Yeah.
Japan. Oh, look at China.
There is no China.
China is not anything.
Oh, what? There's no 2020 for Japan.
It's 2020.
Wow, they're pretty hard.
What else?
Republic of Korea.
Taiwan's got a pretty high score. I don't think they've dropped points in question 1.
Oh, they all got some.
Alright, another country.
Turkmenistan. Mexico.
Syria.
Turkmenistan.
I'll go for.
America. No, Turkmenistan.
Okay, low scores here. Oh, but they all got 7s in question 1.
Oh my.
Oh, great job.
Wait, how did they choose which of the people got get which?
I don't know. They don't tell us where they get them.
Alphabetical order.
It's alphabetical order, yeah. No, it is.
Wait, it is?
Oh, what? Okay, maybe not.
It is. No, wait.
No, it's not.
Not in their country. They do it by preference. Favoritism.
No, they do it by first. Wait, no. They do it by first. No, never mind.
What did America get? I want to see how
They got it first.
I didn't get how to speak.
America got first, yes.
Whoa!
Oh, you have a perfect score.
They're all like Chinese people.
Yeah, they're all Chinese.
Jeffrey Kwan, Luke Roberts, okay, no. Edward Wang, Gandhi.
Jeffrey Kwan. They're all Asian.
It's the population.
Except for number 9.
This is like a left population.
Alright, okay.
Everyone's
Sadly, China didn't
Okay, mom is